Now, let's embark on the compilation process, which begins with a set of source files that you intend to compile. So while it is possible to have just one source files, larger programs typically consist of multiple files. So this approach not only facilitates project management, but also accelerates compilation. So if a single file undergoes changes, you only need to recompile that specific file instead of the entire code base. So C source file contains macros indicated by hashtag define. Now we will open the notepad here, and we will create some define here. So this is the C file macro here. So we will save it as a C main.myapp.c, and here, as you can see here, mousepad indicated that this is something that has macro, and write it on color font. So, and we also have the include here. So the include directive here are used to incorporate header files with .h extensions that the source files relies on. So during the processing phase, these derivatives are expanded, resulting in pure C that is ready for compilation. So to illustrate this process, let's examine an example application using the CC compiler, which serves as the default compiler in many Linux distributions, and including Ubuntu, the operating system installed on like the most popular operating system in Linux. But in Kali Linux you will also get that GCC compiler here. So it's important to keep in mind that the results obtained from other compilers like CLang or Visual Studio will be similar. As mentioned earlier, all code examples in this course will be compiled into 86/64 code unless specified otherwise. So now we will create a C code, and which first we will include the studio hodge, because we will need that for print here. And after that we will define format string, and this format string is going to be s, as you know, and we will also define message, and it's going to be hello world. And after that we will create integer main here, and this integer argc here, character visuals here, and after that we will use the printf function, printf here. First we will pass the format string, and after that we will pass the message, which is hello world, traditional message here, and after that we will return 0. Let's close the braces here. Oops. That's it. And in a moment here you will see what happens with this file in the rest of the compilation process, but for now we will just consider the output of the preprocessing stage. So by default GCC will automatically execute all compilation phases, so you have to explicitly tell it to stop after preprocessing, and show you intermediate output, right? We will tell the GCC that. And here for GCC this can be done using the command GCC. Let's clear here. So GCC uppercase E parameter and P parameter. So where E here tells GCC to stop after processing, and P here causes the compiler to omit debugging information so that the output is a bit cleaner, right? So here we will write GCC EP, and after that we need to go to desktop because we saved this file in desktop, and here let's save it on desktop here. And here we have my app.c and clear. So gcc e p, and after that we will pass our file, which is named my app.c, and here it is. So this is preprocessing phase here, and we have these informations. So the studio.h header is included in this entirety with all of its type definitions, global variables, and functions prototypes copied into the source files. So because this happens for every include directive here, and let's actually copy that. And we will copy that right now, and we will paste and analyze it further. New, and that's it. And here we have integer main here. So, and the preprocessor also fully expands all use of any macros you defined using define. And in this example, this means both arguments here, the format string and here, the format string and message, are evaluated and replaced by the constant strings that they represent here. But strangely, we don't have the format string. So we have this one mistyped this string here, and if we try to do that, like usually compile this my app.c, we will get an error here because we have this string not defined properly because of the word miss here. That's it. And now if we compile this will compile without problem. And let's run this again. And here, as you can see here, we are seeing S and hello world here. So now and as you can see here, this means that both arguments to printf, which is format string, and message are evaluated and replaced by the constant strings that they represents. So this was the preprocessing phase of C and compiled languages. And in next lecture, we will also learn the compilation phase. So I'm waiting you in next lecture.